Hey everyone, and welcome to this explainer. Look, if you're feeling a little bit of fatigue right now in 2026 from hearing about yet another AI chatbot, trust me, you are definitely not alone. We get so hyper-focused on the latest software updates that we completely miss where this technology is having its most massive, tangible impact. And that is right on the factory floor. So today, we're cutting through all that noise.
Because we really have to ask ourselves, where is AI actually making its biggest physical impact? It's sure not in drafting marketing emails. It's happening right now in industrial manufacturing. We're talking about real, fully deployed systems that are fundamentally altering how physical goods are produced, how they're monitored, and how they're conceived all over the globe.
Okay, let's dive into this. It is so easy to get distracted by the hype, the endless digital promises and conversational agents. But the reality is that AI on the factory floor is already a concrete revolution. It's out there driving process optimization, microscopic defect detection, and generative design. We are talking about hard numbers and actual steel here, not just lines of code on a screen.
So here is our quick roadmap for this explainer. We're breaking this down into 3 clear pillars. 1, watching, and how AI predicts machine failures. 2, judging, where it catches invisible flaws. And 3, creating, which is where AI literally becomes the engineer and invents entirely new physical structures.
All right, let's jump straight into number 1, watching, predicting machine failures.
Now, I know the phrase predictive maintenance might sound a little dry, but unplanned downtime is a brutal problem for manufacturers. Think about it. When a machine breaks down without warning, an entire production line just grinds to a halt. To really grasp the macro scale of this problem, just look at this number. $1.4 trillion, trillion with a T. According to 2024 research from Siemens, that is the combined annual cost of unplanned downtime for Fortune Global 500 companies. And to bring that down to a more local level, the Aberdeen Group puts the average cost of unplanned downtime at a staggering $260,000 per hour for just a single facility. When the stakes are $250,000 an hour, simply guessing when a part might break, that's no longer an option.
So Siemens combined its MindSphere IoT platform with Sensei Predictive Maintenance to tackle this exact problem directly. They're currently monitoring over 300 gas turbines globally, and they're pulling data from more than 1,000 sensors on every individual turbine. By constantly analyzing vibrations and data signatures, the AI is achieving a 92% prediction accuracy for component failures. It can actually flag a bearing failure up to 3 weeks before it even breaks. And that results in a 30% reduction in maintenance costs and a massive 40% drop in unplanned downtime.
And these savings, they scale up incredibly fast. $1.2 billion. That's what GE Aerospace is saving every single year by using what are called digital twins, which are basically full virtual replicas of physical jet engines. They run this across more than 35,000 aircraft engines, and they recently even expanded the system with autonomous robotic inspection. Because the AI is watching these digital twins in real time, it's preventing 75,000 flight delays every single year. It cuts unscheduled engine removals right in half, and airlines using it are reporting an absolutely astonishing 99.5% dispatch reliability. In some specific cases, they're getting 60 days of advance warning before a failure.
Even SKF, the world's largest bearing manufacturer, built an AI condition monitoring system trained on millions of historical failure patterns. Their system makes bearings last 40% longer and drops maintenance labor by 35%. The whole system pays for itself in just 12 to 18 months. But honestly, the real takeaway is this. AI isn't replacing maintenance teams. It's just giving them a countdown clock instead of a guessing game. It takes absolute chaos and turns it into a smoothly scheduled Tuesday afternoon repair.
Let's move to our second pillar and see how this builds. Number 2, judging, spotting invisible flaws.
So we're transitioning from predicting when machines will break down to catching bad parts before they ever ship to a customer. Across massive companies like Bosch, Foxconn, and Intel, AI visual inspection systems are hitting a baseline of 99.8% detection accuracy. In automotive lines specifically, this has cut defect escapes, the bad parts that accidentally slip through to buyers, by 83%. But it gets even tighter than that. Over in semiconductor manufacturing, where a single microscopic, entirely invisible flaw can ruin a whole chip, AI detection accuracy reaches 99.95%.
Now, what's really interesting about this is the sheer physical reality of what those percentages actually mean on the floor. These AI systems are spotting flaws as small as 0.1 millimeters, and they are doing it at a blistering pace of over 1,000 units per minute.
There is no human inspection line on Earth that can sustain that kind of speed and microscopic precision without eventually suffering from fatigue-driven errors. The AI just never blinks, and it never gets tired.
And this isn't just about saving a few bucks on scrap parts either. This is a massive consumer safety story. In food and beverage manufacturing, AI-driven inspection has reduced product recalls by a staggering 78%. Unlike the old, fixed, rule-based cameras from a decade ago, these new AI models are trained on millions of labeled defect images. They're continuously learning from every new example that rolls down the line, meaning the longer they run, the smarter and more accurate they get at protecting consumers.
Which brings us to our third and honestly most fascinating pillar. Number 3, creating. AI as the engineer. This is where things escalate. AI shifts from just watching or judging a process to autonomously designing the physical part itself. And the evolution of this generative design has been incredibly fast. It really kicked off back in 2013 when GE ran this Open Global Design Challenge through GrabCAD. They asked engineers worldwide to redesign a standard jet engine bracket using topology optimization. Basically, they let an algorithm figure out the absolute minimum amount of material needed to handle the required load. And it resulted in these incredible, organic, almost bone-like shapes. From there, the idea spread like wildfire into mainstream automotive with GM and right into aerospace with Airbus. The results from that 2013 GE challenge were just jaw-dropping. They had nearly 700 entries come in from 56 countries. Now, the original human-designed bracket weighed 2.033 kilograms. The winning AI-optimized design weighed just 327 grams. That is an 84% weight reduction. And here's the kicker. That incredibly light, skeletal-looking part still passed GE's full load testing to failure. It was literally just as strong using a tiny fraction of the material.
General Motors took this exact concept and put it straight into production using Autodesk's generative design software. Instead of meticulously drawing out a part, GM engineers just input the functional requirements for a seat bracket, like the loads it needed to handle, the mounting points, and the material. The AI then just generated the optimal shape. The new design came out 40% lighter, 20% stronger than the original part, and brilliantly consolidated 8 separate components into one single 3D printed piece.
And this brilliantly illustrates what happens when you scale this concept up. Airbus applied this to an aircraft cabin divider wall for the A320, which they called the bionic partition. Get this, the algorithms they used were actually inspired by slime mold growth patterns and bone structure. The resulting partition was roughly 30 kilograms lighter than the standard design. That's nearly half the weight. Airbus estimated that deploying this across their A320 fleet would save 465,000 metric tons of CO2 emissions every single year. At the time, it was literally the largest 3D printed airplane component ever certified.
So let's pull all this together and look at the actual reality of the factory floor right now. 1. Predictive maintenance is stopping billion-dollar, unplanned downtime in its tracks. 2. AI vision is virtually eliminating human inspection errors at a microscopic scale. And 3. Generative design is inventing these hyper-efficient shapes that a human engineer simply wouldn't ever sketch. This isn't manufacturing adopting AI as some trendy buzzword. AI is out there generating thousands of guaranteed strong options, and engineers are just picking the best ones to manufacture.
Which leaves us with this final, kind of provocative thought. What happens when AI doesn't just watch our machines or inspect our parts, but consistently outdesigns our very best engineers from scratch? We are just scratching the surface here. If you want a deeper explainer on the materials science side of this, specifically how these crazy, alien-looking generative design parts hold up structurally in the real world, let me know in the comments. I would absolutely love to break that down for you next. Keep learning, keep questioning, and I'll see you in the next one.